data vault side. It's a lot on data warehousing. So I'm assuming it's a combination of them all.
Yeah.
Fantastic. Excellent. All yours, sir.
Sure. Okay. The typical first question, can everyone see my screen? Or at least how
Yes.
you can just...
Yes. All good.
All right. So before I start, just a quick intro to myself. Corné Potgieter. I currently work as a data consultant through a company called Sparkle in Belgium, but I'm based in Cape Town. Started off my BI career, I started off in a SAP, but luckily got out of that. Sorry for anyone still left in SAP, but I moved over, worked for Deloitte Analytics for a couple of years on large BI program. I then joined a data warehouse automation vendor. So I was a solution architect there. So that's also, I guess, where my passion for automation and data warehousing started. Or before that, obviously, because that's why I joined them. And then I went back into consulting after that. So that's just a bit of background as to my experience with data warehousing and automation specifically. So before we start, maybe some definitions. I think some will be obvious, some will maybe not be so obvious, but I just want to make sure we start with the same, let's say, terminology before we dive into a bit more detail. So what is data warehouse automation? This is my definition. This is not one I Googled or asked ChatGPT. This is just purely kind of what I really believe data warehouse automation is and what the power behind it is. So it's really about using your metadata and making sure you capture enough metadata in your data warehouse design. Now, whether you do data warehouse design by doing a conceptual and a logical model like I'm going to do a bit of today, or whether you do it in metadata tables in your target platform, or however you do your data warehouse design, it's really about capturing enough metadata at design time so that you can use it for automation purposes. You then use templates, and that differs from the technologies or software that you can use, but you can use what you would understand to be a template that uses this metadata and generates certain components in your data warehouse, like the DDL and the DML. So those are two, or one item that I'm going to discuss in a bit more detail, but anything you really can automate that you can use the metadata for, or that you can use metadata to automate. Not everything can be automated. Not everything should be automated. But I think if you look hard enough, you will be surprised at the amount of repeatable patterns that do exist within your data warehouse design. So if something changes in the design, or if something changes and you have to update your design, you can simply rerun the template engine and whatever software that might be, or whether it's homegrown. You then regenerate the applicable code. So just a very basic data modeling recap and maybe kind of the steps that I'm going to take in this explanation today. So we want to start with the conceptual model, where we really talk about the core business concepts of the process in question, define the relationships between these concepts. So this is really at a business level. This is not, shouldn't think technically at this point. Have a business glossary of what these concepts mean, and define that and really understand with your business what these entities mean, so that everybody speaks the same language when you use certain business terms. We're going to then dive into the more detail, where we design a logical model, have attributes, definitions, relationships between attributes of different entities, do some source mappings to the logical entities that we have defined and the sources we have in our business, and then any other further augmenting of that metadata for the entities and attributes. Then we're going to generate a physical model, and in this case, our data warehouse physical model, not our enterprise or application design, but just how we want to design our data warehouse, whether you have loading tables, staging tables, and this is really target specific. So conceptual to logical is really target agnostic. And when we get to physical, it's obviously target specific. So the specific way in which you design your physical model is dependent also on the technology that you choose. But whether you have loading tables, staging tables, whether you have an enterprise data warehouse or a data vault, or if you use Kimball dimensional modeling on top of it, all of those questions. Data vault, I want to ask this now because I am going to specify some data vault things just to make sure everybody is awake. I just want to quickly ask if you can do a quick poll. So you can just go to this website and add that code and just answer one of these 4 questions or scan the QR code. Yeah. Well, within a minute, I just want to see the audience just in terms of where you are with data vault. I just want to know how much I maybe need to spell out. Just go through the process myself. There we go. Give 30 seconds more. Okay, quite a lot of people have never heard of it, so I might just need to. Yeah, okay. So I think this number is a bit higher than I thought, so I'll just give a basic overview. I'm not going to have time to go through the details, but I will give a basic overview. So Data Vault is really the methodology, and there's different Data Vault methodologies also in the market, but it's really about the way you structure your data in your data warehouse. For example, Data Vault, if you hear Data Vault 2.0, that is a methodology developed by Dan Lindstedt about it. And it's not just technically how you implement your Data Vault like physically, but also kind of the whole process around working in a BI program that you use Data Vault for. But in a nutshell, you have 3 basic objects. I'm not going to go into further detail or the other objects, but your core business concepts are modeled in a hub where you have your business key or your unique key that gets captured there. All of your attributes or descriptive attributes about that business entity are stored in satellites, and your relationships between business concepts are stored in a link table. So it's a way of denormalize. Is that the right way around? Denormalizing, no, hypernormalize. So it's the way you normalize your structure. And there are several benefits to it. One of them being it's very, very repeatable in nature. So it's a very good candidate for automation. And that's one of the components that I'm going to talk about today. So I just want to give a brief introduction of what Data Vault means before I continue. I know it's not a real detailed explanation, but unfortunately I don't have. Most people do have an idea of what Data Vault is. I just wanted to give a brief introduction. So today's scenario that I want to talk through is a company called Cinema One. It's a fictitious company, but I do want to say that I've tried to make it as an easy example. But I've worked at least 3 companies, maybe some a bit longer than others, but 3 companies which I've seen a very similar approach. It's actually quite interesting, and I personally like this approach, but where they used a fairly similar approach. They used 2 technologies to deploy some of their code in, and yeah, but you'll see in this scenario. But so it's really something I haven't completely made up the names and so on. I've made up not the real scenario behind it. So Cinema One is a cinema business which has a nationwide presence. A few years ago, they adopted a software called Showtime, and it has been systematically rolled out to their cinemas. Some of the cinemas were quite small and some were acquired, so it was not mandatory to move on to the software. So you have some cinemas, the bulk of them, that uses the software, and some of them who don't. Till now, they've heavily relied on siloed data warehouses for the reporting needs, but they would like to implement a more scalable data warehouse across the company. They intend to follow a data mesh type architecture. I had there in comments because one of their data architects went to a data event, but I do often see people are very excited about data mesh and they don't really know what it means, or they like the wording around it, but often when it comes to implementation time, it's a bit harder. But anyway, be that as it may, they intend to follow a data mesh type architecture where the teams, the different teams, can have freedom in building their data products in a decentralized way. However, certain components should be centralized and there should be central standards applied to them. So they have data modelers or data modeling team that is responsible for the conceptual and logical models of the business processes. Some of the core business and especially the Showtime sources, Showtime being that SaaS software, they've earmarked to follow a data vault approach where the central team will design the data vault, or at least a raw vault, and some of the repeatable patterns and components, and it will have centralized standards applied to them. And then the rest of the teams that want to consume it, they are free to do whatever they want to. Well, let's say freedom, a new term I heard recently, freedom in a box. You have certain constraints, you can do whatever you want within those constraints. And the chosen architectures and technologies is they want to use Snowflake for the data vault centralized components. And purely because these smaller teams are more used to working in SQL, stored procedures, SQL code, they will at least want to use it in the cloud, so Azure SQL, but those teams can continue building or should at least move their current SQL warehouses to the cloud and build on this base model. So they have a model which they deem to be, it should come within the central scope that goes to Snowflake, and those ones where they just want to be, they give a little bit of standardization, so they don't want to influence at all the way the logic is implemented, but they do want to create a base model, and this base model is simply a process of replicating the data, or at least loading the data into ADLS, and then have Azure SQL having the tables historized, as well as an ODS, which just has the current snapshot of the data. So one set of data is just a replica of the source tables, and the one has the source tables historized. So then the data teams can do whatever they want on that. So the scenario, just visually, we want to build up a conceptual model, embellish it further with with more steps to make the logical model complete, so attributes, relationships, and further augmenting of the metadata to make it useful for a template-driven code generation approach. So we want to use, and this is really the important step, so that we capture as much metadata as we need by design time, so that we can use a template-driven code generation approach. I'm not going to, at the end, I'm going to maybe mention some software that you can use, some options, but I'm not going to open up a template-driven code generation tool. There are several options and we can discuss that. But basically, in that concept that I explained, that if you have enough metadata in your logical model, you then build templates that takes that metadata and it can generate the code for any platform. So that's the process we're going to go through. So in the conceptual model, we want to define our core business concepts. So in the case of a cinema business, I'll show you, there's a bit more detail to this, but this is just to visually explain what we want to do. So we want to define what are these core business concepts. We have a customer on the one side. Customer does a reservation for a movie. The movie has different screening times. So all these concepts are related to each other. We define in our business glossary what do these terms mean, so that we all talk the same language when we talk about these business terms. And we store that somewhere on a data governance tool or something like that, but somewhere where everybody can reference what these core business concepts mean. We define how these entities are related to each other. One movie can be available in multiple screenings. Reservation can have, or one customer can have multiple reservations, etc. So I'm not going to build out an entire data model. Just want to kind of talk through the different steps that one will take. So this is just to maybe have the concepts a bit more with a practical example. So a screening would be that the movie Oppenheimer shows at 8 o'clock on Tuesdays in Cinema 1, but it's not a specific Tuesday. It's just these are the current screenings that are taking place. A reservation is so the table is just to kind of illustrate what this potentially could look like in a data set, just to give you a bit more practical feel for what the data will look like. So a reservation, a unique reservation, will be for a specific customer, for a specific screening. It will also have seat numbers and so on, but I'm not going to specify that. But a reservation is linked to a customer. Customer could have a loyalty program. Customer will have payment details, address, and that's about as far as I'm going to take it. So you build up your core business concepts and how they relate to each other, not with the technical information yet. This was just to give you a bit of an insight as to what this means. So you start there, you talk to business, you understand the core business concepts. From here, you embellish that model and you start specifying detailed attributes of these entities. So we specify all the attributes that we want in our logical model. And this is not looking at the sources. We're not reverse engineering it from the sources. We start with what do we need. Obviously, you look at your sources to get an idea of what there is, but this is really the information that is important to us as a business in terms of these core business concepts. So the unique identifier for the customer, cell phone number of the customer, what's the movie duration, etc. Next step is we can map this to our sources. I want to pause here a bit because it's going to become important a bit later on. And this is not, so we know that Showtime has a JSON API so an API that produces a JSON file. So all we want to do at this step is just capture enough metadata so that we can use it later on. We don't obviously want to load anything because these files could be huge. So we just want to load a sample and map, not load, we just want to map a sample source file to the target logical model. Because we want to know how deep in this JSON file is this data stored, and we purely want that so that we can use it for automation purposes a bit later on. So this is an example of the API that gets sent from the software, and I didn't make it too complicated. Just to say that, okay, that's the reservation ID that we want to map to the key. That's, oops, I actually swapped those two around. I see, but you get the idea. So this is the Showtime source that we want to map to the reservation business entity, and we do a field level mapping of that. We also have the smaller entities. So again, the reason it might not be necessary to always do this mapping, but the more metadata you can capture at this point, the more you can automate later on. So here is an example of some of the cinema houses that they send Excel extracts from their local database once a week. And they also load it to ADLS. So we just take a sample CSV file and we say, okay, so we're going to map for cinema house ABC, we're going to map it like this. And again, it's just capturing to know that this column name in the file maps to this logical attribute in our logical model. So now we have a mapping of the Showtime source. We've decided, so the scenario that I sketched in the beginning, we decided that the common model or the Showtime source, we want to generate a data vault in Snowflake. So now we have that metadata. It's the same entity, it's the same fields, but we've added a source mapping for Showtime that indicates that this needs to become part of the data vault central model. The cinema house ABC, we tag it as base only or not data vault, or however you want to tag it, by saying that we know this one is not going to form part of our Snowflake data warehouse, data vault data warehouse. We want to just generate a base model for those teams to continue building their data assets as they wish. We are not going to prescribe anything more than that base model for them. Another important thing that should be done at this point is to tag sensitive information. So whether it's POPI in South Africa, whether it's GDPR in the UK, and I'm not sure what the names are for other jurisdictions, but we want to tag the specific personal identifiable information, as an example, in our logical entity. I didn't tag everything that's probably important, but it's just to prove the point. So adding more metadata to those attributes, just saying this is sensitive information. Treat them a little bit differently when we get to the data warehouse. Also, an example that I've seen before is adding pseudo business logic. So that the modelers will not know how to build technically a field called recommend loyalty. They don't know you have to join 10 tables and do group buys, etc. They just know, and they just sketch the picture of what needs to be done. So let's assume there's a recommend loyalty attribute that you want to do some analysis on, because if the customer was just maybe on one level higher of a loyalty program, you could have gotten a 15% additional discount. So what you do here is you add that field because it's still part of the logical model. It's not available at the source, but you just add some pseudo logic to say how you potentially can have this calculated, and add as much information as possible. Even if you know what the source fields or the sources are that has this information, you can add all of that. And then you can decide, if you have enough metadata, you can decide how much you want to automate with that. If it's just generating the DDL in that one column, fine. If you can actually generate code behind it, even better. But this is an example of things you can add in the logical model. Okay, so now that we have all of that metadata, what we want to do is we want to generate for the Snowflake central data warehouse, we want to generate the loading mechanism into the stage or the external stage table in Snowflake, some data vault stage tables, and then hubs, satellites, and link tables. This is really the raw data vault. And for the base model, we want to generate, and in Azure SQL, we want to generate a landing zone where we take like a snapshot of when we started loading the data together with all the change tracking. So these will be two tables. And we want to generate a historized or a merged table with a kind of a type 2 history for that customer, but also a snapshot view of what that customer table looks like in source. So then these teams can just decide what they want to do with it with no further prescription from the centralized team. Okay, so just end to end, what do we want to do? We're starting with the conceptual model, embellishing that into the logical model with further metadata tagging enhancements, and then using this template-driven approach to generate a data vault on Snowflake and a base module on Azure. And then the data teams can then build out their data marts. So this team wants to use the centralized data model in Snowflake, and this team continues as per normal to build out their dimensional model in Azure SQL. I think there's one example which I'll go into a bit detail on this access layer, but if for things like security, without going into too much detail, one of the things I see often with Data Vault is that the centralized teams, they generate like an access layer. There's different names for this layer I've seen in the market, but it's basically some of these teams don't have a clue about Data Vault. So these views are kind of denormalizing the tables again. So creating the joins for the data mart teams. It's doing some specific objects that make it easier for consumption, and it also applies some security policies already. So you have this access layer in the middle. So this is the architecture that for this scenario we will go with. Okay, so with that kind of background of where we want to start and what we want to generate, let's just highlight 3 aspects of this architecture that we should be automating, or at least can automate. I think the first one is the obvious one. So the data definition and data manipulation, so DDL statements, code generation behind everything. So if we look at the core data model, is that what I called it previously? So the data vault centralized one. So in our logical model, we said we're going to define attributes and we're going to tag it with metadata. So in your logical model is where you would tag what is the business keys, what is the link business keys, what is the... So I'm not using Data Vault terminology. So if, for those who've never heard of Data Vault, I apologize, but there's very specific Data Vault terminology on how you tag the attribute. So for example, also the behavior of the satellite attribute. So all of those things is what you will tag in the logical model. And that metadata, you capture it properly, is then used in your templates to generate the hubs. So the structure of the hubs, hub has a business key, a hash key, load date, and the source. I think those are the kind of prescribed ones. Your satellites has a very specific structure, but all of those things are very, what's the word I'm looking for? It's very, automation is very easy to apply on that because there's a very strict pattern that you can follow. So if you've got the correct metadata tagged in your logical model, you can simply use a templates to generate the DDL for all of these objects. You can also generate the insert statements into these objects because they also follow a very, very structured pattern. So why I paused earlier on the map to sources. So remember the time we spoke, I think I actually have it here. Yeah, so when we mapped this JSON file, now we can use that information. So I think there's a couple of ways one can do it, but you can now use that metadata to generate the Snowflake code. And one option is you just simply copy, use a copy command from ADLS, where you create an external stage and you have a copy command that inserts the data into a variant column in Snowflake. And then you can use JSON SQL statements or the JSON parsing functionality within Snowflake to flatten that JSON structure. And you can automate that because you've captured enough of the metadata to know how deep in that JSON structure is which field. So you've got all of that information, so you can automate that full data flow using a variant column. The CSV is even easier, not too much you need to do there, but you can create these statements. I've also added Snowpipe as an example. So some of the automation that I've seen is if you kind of have these incremental files that get written to a data lake source like ADLS, you can create a Snowpipe in Snowflake that then as soon as files land in the ADLS, you can send these to the stage table. You can then create tasks and streams. So over the right way around, the streams kind of checks when there's an update in the stage table, and the task is something you define that gets then triggered based on that. So then you can do an update to your data vault stage based on a change in your source. There's often having this kind of real-time or near real-time pipelines is a very people are always very excited about it, but they aren't always practical. So there is cases for batch and there's cases for these real-time, and it's just finding the right balance. But I'm not here to debate which one is better in which scenario, but you can definitely automate both. So if you've got the right metadata with the mapping of this JSON file or the CSV files, you can automate all of that code. Next one, and you can do the same for the Azure SQL or the base model. So here it's just obviously a little different. Here you can either create, because an ADF pipeline you can also generate via code, maybe by Python or via like a PowerShell thing. You can create a pipeline using a JSON input. That's maybe a bit complicated, but you can do it. I've seen it done, or you can just generate stored procedures that moves data into these historized data stores and operational data stores. But again, if you've got the metadata, you can generate code to do it. So the last example in the data definition and data manipulation example or scenario. So I mentioned the business logic in the pseudocode. So here it really depends on how much you can automate. I would say in terms of data vault, at the very least, you can generate the DDL for a business vault satellite. So if you have attributes that you know don't, or you create your logical model, you start mapping your sources, and you realize there's actually no this is a field that needs to be calculated. So you add the pseudocode. You can at the very least generate a business vault satellite. And then you pass that metadata to the data engineer and tell him, this is how I think the data should be loaded, or this is the sources that you can use, but how you load that business vault satellite is up to you. You still have to use a standardized way in the sense that you have to generate a hash key that corresponds with the hub. You have to have a load date, things like that. But if you want to join 10 tables or have several stage tables in between, that's all up to you. I'm trusting you to do it in the most efficient way. But I'm going to at least tell you what the structure is of that business satellite. Okay, so just want to kind of pause there and think if I've mentioned enough. Yeah, I think we're running out of time. So this is kind of the obvious one. This is the bulk of the information that you definitely want to automate. Another thing that you want to automate is some of the security features. So you'll also remember I said in your logical model, we want to tag sensitivity. So we said we'll tag customer name and number as personal identifiable information. So Howard, is that a question for me?
Yeah, I just wanted to ask you on your previous slide, in terms of you were sort of saying I can do a minimum. If I do a minimum, then I'm assuming that people will add on to the snowflake, and then do you have problems with reverse engineering it, or can you keep on generating the next update, or I feel that if you don't do a full job, then you probably are going to have challenges enhancing or going to the next version. Is that right? Or?
So you mean if you have a pseudocode, or if you have business logic attributes, but you don't generate the whole process?
Correct. And then you almost assuming that someone will handcraft it or the engineer will build it on their own.
Yeah.
Then as soon as people start doing things on their own, then you may have problems updating it.
Yeah, I would say yes. That is definitely a risk. So what I've seen how this can work is your logical model is still the truth for how that business vault satellite. So you still have very strict standards of how that satellite should look.
Okay.
And then you can either say, if you have new attributes, or new business rule attributes, it needs to go to a new satellite. So that way you don't interfere with an old one, but you have the risk of having a lot of satellites. So I think there does need to be some conversation, data modeler and data engineer, but the logical model should be the truth of what the satellite looks like. I think you can, and the rest is really about version management and making sure your modeler and your data engineer doesn't completely ignore each other. There still has to be a conversation, but yeah, I think if you set some specific guardrails, it can work. And I do want to make the point that I think it's always important to ask, what can you automate and what should you not automate?
Right.
If you can automate it fully, you should. In this case, I don't think you should, because I found that interfering too much with business logic automatically, often it's by elbow grease. You have to figure out what's the best way of joining this specific set of data. You might have to do a bit of a jump, hop, and a skip to get the data in there correctly. So there is often I would say, the urge to even automate that part, but I think that is dangerous. I would say that's really up to the techies to really figure out what would be the best way to do it. But you should at least prescribe what the target structure should look like. Okay, sorry, I do want to just quickly carry on. Okay, so in terms of security, yeah, so you tag your attributes as being sensitive in the data vault landscape. That can be done in a couple of different ways, but typically you can separate your satellites, your let's say your sensitive data can go to a different satellite. So, and you can restrict access to that specific satellite. You can even put it in the same satellite and have kind of column level restrictions, but I've seen it done mostly by separating the satellites, even having those satellites in a different schema. and having certain access policies on that schema. So in this example, what I'm showing is that you would split it out into your second satellite. You would have in your access layer where you denormalize your data again, where you now have to join it back. Here you would have, for example, on Snowflake, you can have masking policies or row level access, but I'm going to show that in a minute. You can have a masking policy on that column, and then you can create this view on this access layer schema to just kind of hide those columns that are sensitive. So you can use normal SQL language, which is normally the easiest to generate using templates. You can use normal SQL language to create policies. In Snowflake, you can, I think you can do it in most languages, but in Snowflake, you can create a masking policy and you can build it into your DDL generation. So it's technically part of the DDL generation, but I do want to kind of separate it out. I think I call it DCL, data control language. So having almost separate templates or a separate piece of templates specifically around this type of thing. So depending on your architecture, you can automate the code that actually controls who has access to certain data. And with Data Vault, I believe it's a bit easier to define where that data should go. And this one I didn't mention earlier, but there could be other metadata, which is regarding sensitivity, to say that for this data, the customers only in this region. So if I'm a sales manager for Western Cape, I'm only supposed to see customers coming from the Western Cape. So that type of metadata can also be tagged in your logical model, and then you can create kind of row level access policies as well that can be applied to the same view, so that if I have a specific role when I log into Snowflake or another tool, but as long as your credentials get passed through, if I'm logging in with a certain role as sales manager or maybe sales manager of a specific region, then it will only show me that row level access or those rows that are applicable to me. So this is really just to show that depending on how well you've tagged your metadata in source, you can use your templates to generate how you handle security at that level. Performance being the last one, also maybe a not so obvious one, because this isn't always possible, but I do want to add it there that I think it often gets overlooked. So some performance tweaks, or let's say the way you define your data objects, can actually be done at design time, because especially with Data Vault, again, there are several query patterns that we already know by the time of design. We've designed our objects so that they are queried in a specific way. And if you know how your tables and objects will be queried, you can create indexes or cluster them in a different way so that it is more optimal. I'm just going to zoom into this picture, something I use for a different article. So the way that data gets inserted into satellites, it follows a standardized insert pattern. It allows for basic rules to be followed around distribution. So platforms like Synapse, you can define your distribution. You can create things like cluster keys in Snowflake. So this is very target dependent, obviously. Like what controls you do have in order to spread your data across nodes, if you're using like an MPP platform. And at design time, you can create these cluster keys for your satellites because you know what the insert patterns are, but also querying out of. So this is also where that access layer becomes important. So that's a layer that you can actually automate a lot of it. And then you can generate the same type of selection queries. And you can also define how the distribution of your data should look like. I worked with a guy who did quite a lot of work on Synapse, especially on link tables and driving keys on link tables. So yeah, because it follows a very, very specific way in which you query the data from those link tables using the driving key. So there's a very set pattern you can use for doing your distribution of data. It just helps with query performance. It's not going to solve all your problems, but there are lots of levers that you can pull at design time. I think that's the key message that I want to do there. There's definitions you can do at design time, and then there's definitions that you can do kind of at periodic corrections. So even, or maybe you don't have control over some of the data assets or the data objects. Maybe it's one of the objects that sits with outside of your, let's say, the automation object, so the raw vault, or outside of the raw vault, so in your dimensions or wherever. So it can happen that the data can become skew. So there was maybe a key or something that was used for distribution, and you see that most data is actually for, in this scenario, California. So the data is not well distributed. So if you use that column to do a lot of your filtering, it's going to affect your performance. So, but this is something that can periodically be checked, and you can alter your cluster key. So this is also something I think you can add to automation. It's not at design time, but it is a script or a procedure that you can generate at design time to kind of give you a weekly report of data that has become skew. And then you can run periodic corrections on that data. So kind of in the redesign or design bucket, you can do indexing for things like SQL Server, different types of indexes. Clustering keys is what you can do for Snowflake. You can also decide by at design time, what do you want to use a materialized view for or not? I don't know it in that much detail, but I know there are some benefits with using materialized views. You can also, in this bucket of optimized tables, this is a bit of detail into Data Vault that I'm not going to have time to jump into, but your point-in-time tables, there are different methods for generating point-in-time tables. It's purely there for performance reasons, that you have these very large satellite tables in your Data Vault, but you may be only interested in a weekly frequency or a daily frequency, or you're only interested in the current view of it. So you can, at design time, often already say that, you know what, I know this satellite is going to have 1 billion rows. So I would rather also add in my generation a table, a point-in-time table, and generate the code for it that on a daily or a weekly basis aggregates that data and puts it in a point-in-time table with only the keys. So it's a very small table, and then you build your access queries from that table instead of the satellite. The satellite keeps all history, but if you know by design time that there's going to be use cases that does not need that much granularity, you can already build it in. And distribution, like I mentioned with Synapse. So Synapse has this width distribution syntax. I think this is Snowflake. This is kind of a sample of a query, I think it's Snowflake, that you can run to check skewness of data. And this is just a SQL index. So these kind of periodic checks to see if your data has become skew, and then you can decide what you want to do with it. So if you're making good time, yes. So just some example software. I've worked with Warescape extensively, so I'm maybe a bit more biased towards them, but Coalesce, so it's a kind of a modeling and data warehouse generation tool. So it handles kind of from the modeling to the actual generation of code. Coalesce is it's much more modern architecture. So you use like YAML files, very similar to DBT, but you also have this kind of templates that you can build Data Vault objects, or you can build your own templates. But it is also, it's only at the moment capable of doing Snowflake. It only integrates with Snowflake. At DBT, I personally like DBT. The missing piece in DBT is kind of this modeling aspect, where you have a logical or a conceptual model, and you use that metadata to generate your DBT models. But I've actually have some friends who's built, I think they use kind of open source modeling tools, and then they build a Python program that fetches the metadata from these open source modeling tools, and it generates the YAML files for DBT, or these .SQL files that DBT needs to build it. So maybe the one comment there is, if DBT can just have a modeling tool as well, I think that would be great. But you can either use the free or the paid version. Time extender I haven't used much, but I know that it's kind of a similar concept of generating the code for you. Data Vault Builder, obviously Data Vault. Vault Speed is Data Vault. And Click has got a lot of tools, but Click also has Click Compose, which yeah, also does a bit of it. I won't elaborate too much detail unless someone has a question, but I've a lot more knowledge of Warescape. I've used Click Compose quite a lot. I've used DBT quite a lot, Voltspeed a little bit, and Coalesce to an extent. So I can answer some questions if people do want to know, but these are just some of the tools that are available if you want to go and play around and see what data automation can do. Okay, questions. I think we've got about 5 minutes to maybe answer some questions.
Thanks, Corné. Yes, we actually had the data vault builders on. They presented a webinar and they demonstrated this reverse engineering or
Christian, yeah.
doing from that. Yeah, so they've done a good job in that automation as well. We've had a few questions. They seem to be mainly answered, but we'll just check that you agree with them. I think the first one that Andrew asked was sort of what's the difference between what gets stored in the hub and what gets stored on the satellite, and then it's really Sven actually answered there where the hub is the key and the satellites have the historization or the attributes.
Yeah.
It was and then Michael asked where the facts get stored, and that's in the link tables. And there was a really nice.
Yeah, that's maybe just on that. The fact data I can tell you it's not stored. It's definitely not stored in the hub, but you could. That's more a modeling question whether you model certain. Let's say it's like an invoice. If you model it as a hub or if it's purely a link, I think there's different interpretations of that or different opinions on that. But it will always be the real bulk of the data will be stored in satellites. If the satellite either hangs off of a link table, which is really just supposed to be the relationship between different hubs. So the satellite can either hang off of the link tables or the satellites can hang off of a hub. But your descriptive attributes, whether it is master data, like regions or whatever, or if it's kind of customer data, or if it's real transactional data, it would sit in a satellite.
Just to confirm that, so like master data would be satellite off a hub, and then when it comes to the fact tables, it's going to be surrounding the link table. But you're saying that you can also add satellite attributes to the link table, and the purpose there would be to add more detail to your fact tables.
Sorry, I didn't quite follow that. There is some scenarios where you can not have a satellite off of the link table. I know Renko and the Data Vault Ensemble group, I think they don't actually recommend satellites of link tables. They would rather model it as a hub and then have a satellite off of that hub.
Okay.
I would personally also say that even if you do have satellites of link tables, your link table for me should just have your relationships. There are some scenarios where you can have a what's it called? I can't remember the terminology now for the link table, but you can have the data in the link table. I personally would like it to, if it's standardized and you have all descriptive attributes, doesn't matter what the descriptive attribute is about, if it is in a satellite. So the hub table is supposed to be very thin. It's the hub key, the hash key, the business key, and some metadata fields. And the link table should be the hub of the hub key or the hash key of this hub, the hash key of another hub. So only the relationships and also some metadata fields. So both of those tables should be very thin and basically just keys. And your satellite should be where your historization happens.
Right. Okay. Then Henny Berta asked, I gather that the access view is denormalized dimensional modeling. Do you see a need to persist the denormalized dimensional model, or do you only introduce a virtualized representation of the dimensional model?
Yeah, that for me is, you should take a pragmatic approach, in my opinion. You can start with virtual. If you're using a data vault, and you've historized all of your satellites in both your raw vault and your business vault, there is no, let's say, a business need to persist it again in your data mart. You should be able to recreate your entire data mart at any given moment. But there's always a performance reason that you want to do it. And that's where pit tables comes in. So this is more case by case. I've seen teams very enthusiastically starting with virtualized dimensions and fact tables, and then it breaks the first time you try to load it, and then they repersist it again. But the repersistence is not, it's not adding any context to the data. It's simply for performance reasons. The history should all be in the data vault. If you don't use data vault, then it's a different question, because if you are building your dimensional model straight from those historized data sets. Now, I guess if you have a historized data store, you can also recreate your dimensions. I think there's some scenarios where that might be tricky, but if you're using your dimensional model to store history, then obviously you can't just drop and recreate it. So if you are using, if the tempo at which you load your dimensional model is what defines the history that you keep, then you don't have a fallback. You cannot drop and recreate that data mart at any point in time. That is your history, and you have to preserve it.
Okay.
I hope that answered the question.
So that's dealing with that slowly changing data that you're referring to.
Yeah.
Okay. All right. I think those are all the questions. So maybe just opening it up onto the floor. Anybody have any further questions other than the ones that we've spoken about? If you can put your hand up, that would be great. We've got a question from Henny. Yes, Henny.
Thanks, Howard. Yeah, Corné, just a last question from my side. You've mentioned centralized up until some point and then decentralizing. So the central data team, I assume they're responsible for everything, including the data vault loads, and probably the access views that will be driven by the decentralized business units, right? For a very specific business function capability in mind.
I would have to remember what's possible in the access view. So definitely the central team, in my opinion, is better if they, but I'm just finding my Teams button. Centralized team defines the raw data vault. So I'm not sure if you know the difference between a raw data vault and a business data vault, but raw data vault is kind of doing only a specific set of things to your data. It is definitely finding the right business concepts, business keys, but it's not adding any logic yet. That's definitely a centralized team thing. How you ingest data, I believe, is something that the central team should do. Standardize on one or two approaches, because often you have a nice database that you can replicate, and often you don't. You have files. So you kind of have to treat at least one or two different scenarios with ingestion, and for me, that's better if it's done in a central team. So the central team defines how the raw data vault gets created, as well as the base model in this one. In here is a block I didn't draw, but the business vault is just a logical separation. I think you can generate at least a DDL for the business vault, but it shouldn't be prescriptive. If the data modelers cannot define the pseudo logic or even add the attributes in the logical model, it should not stop the business teams from creating their own business vault entities. So that's where you add business logic. So the teams should be able to create their own business vault objects. The prerequisite there is you do need to understand data vault. If you do business logic in your business vault and business logic in your dimensional model, I think you are going to run into trouble, because then after 2 years, no one will know if they look at data here, was it changed by a team member here, or was it changed in your business data vault? So if you're going with the centralized model, you do need to have a decentralized team, or at least people in your team that is responsible for the business vault. So just the component where business logic gets added. The access layer, I would also say, is maybe I didn't draw it in exactly the same place, but for example, if you have let's say you have HR data in here, in a satellite, that table should get restricted via the access layer, even to someone else that wants to build other tables in the business vault. So the business vault, even the business satellite tables, should access the rest of the objects through an access layer. Now, yeah, I think that's actually how it was done at one place. So it's always through the access layer, even if you're putting things back into the business vault. The access layer for me the way it gets generated can be handled by the central team, but your separate teams should be able to define what that layer, or what fields at least, should be in it. So let's say in a utopian, what's the word? An ideal world, the business teams would have a nice dashboard somewhere saying, customer data, like a self-service BI. I think that's kind of the end goal here. Is if the data team say, we want customer, okay, these are all my attributes. So they just pick attributes, and then boom, a view gets generated for them that already does all of the joins from the different satellites, so that this team they don't know how to do the joins, so they don't care. They just get a nice view with the right security policies already applied, and then they can use it. For me, that's the ideal world. So they can define on a metadata level what they want, but the central team still controls how that gets generated. I think it's not really that ideal in practice, but a combination of that, where how it gets created, kind of the structure of it, should be defined centrally, but the data team should be able to, in a flexible way, request the data that they need. Because I think this could be a bottleneck. If they have to log a Jira ticket and wait 2 weeks before a view gets created, then you've missed something. Then you haven't really, I would say, you're not living the data mesh dream. You are just going to frustrate this data mart team, and they're going to bypass this whole thing and query a table directly from the source, which I've seen a lot of times. If you frustrate these teams, you're going to get people that bypass the system. So I would say, if there's no automated way to do this, then you should give the data teams a bit more accessibility to the data vault data. So yeah, there was a lot of things I said there. I think this is not an ideal. As I said, I think I know what the ideal picture looks like, but rarely have I seen the ideal. I've honestly never seen a real fully fleshed self-service BI type of platform working. It's always a bit of a mixture. Or certain things are good, certain things are not so good. So I can talk to the ideal picture, and I can kind of say what I see in practice.
Thanks, Corné. Answered my question. Thank you. Thanks, Howard.
Sorry, I probably over-answered your question. I tend to do that.
All good, thanks.
A lot of it's all the practicality. If you can automate it simply, and the people can get what they want by just using some sort of front end, great. As soon as that takes time, then you're going to run into some challenges where they have to do something urgently and they can't wait for you, and there's a problem coming there.
Yeah, exactly.
Any other questions? Great. Corné, so many people have said thanks very much. Great presentation and food for thought. Really enjoyed the presentation that you gave. Nice to see all of it coming together. Thank you so much. Thank you for your effort and putting it all together for us. Appreciate it.
Thank you. No problem. Thanks.
Cheers, everybody.
Cheers, all.
Howard. bye. Good
Bye-bye.
night.
Oh, there is someone. Mbando Ububu.
Or maybe he wanted to wave. I think he wanted to
I think
wave
so.
and then-
Yeah. I think he
Okay.
put a hand up to wave. Excellent.
Okay, thank you.
Thanks, Corné.
Bye-bye.
Have a good evening.